The previous lecture, we have started with the basics of the probability. We have seen the definition of the probability, and then we have also seen the remarks based on the definition, or we have seen some standard random experiments. Okay, so now we'll see some basic examples. Okay, so let us have the examples based on the definition of probability. Okay. Okay. So we go with the example. So a coin. So here, when we consider a coin, so we always consider fair coin unless and until it is mentioned that it is biased. Okay, so this is a fair coin. Okay, so coin is tossed 3 times, then find the probability of following. Okay, so first we have exactly 2 heads. Second, we have at least 2 heads. Third, we have at most 2 heads. And fourth, we have 4 heads. Okay, so here very important thing that we need to understand how we go with the exactly, how we go with the at least, how we go with the at most. Okay, so these are the things that we need to understand. So in one example only, I am considering this all the terms. What is meant by exactly, what is meant by at least, what is meant by at most, and we have no heads. Okay, so this is what the question given to us. Now, what is given? A coin is tossed 3 times. So this is our random experiment. So our random experiment is coin tossing 3 times. Okay. Now first we need to understand what are the sample points. Okay. So what is the sample space we have? So first always we have to write the sample space, and these are the events we have. Okay, so these events we'll see one by one, but first we need to write the sample space. Okay, so let us write the sample space first. So we go with the solution. Okay, let S be the sample space when a coin is tossed 3 times. Okay, so this is our random experiment of coin tossing 3 times. And now yes be the sample space. So what is mean by sample space? So sample space is the set of all possible outcomes. Okay, so all possible outcomes. So let us see what may be the all possible outcomes. Okay, so we can see either we'll have head or we'll have tail. So uh, we can have either we'll have head or we'll have tail for the first toss, either we'll have head or tail for the second toss, either we'll have head or tail for the third toss. Okay, so this is the first toss, this is the second toss, and this is the third toss. Okay, so in first toss we'll get head or tail, in second toss we'll get head or tail, in third toss we'll get head or tail. Okay, now we have to write this all possible combinations. Okay, so for example, we'll get first head. Okay, suppose we get first head, and then or we start with no head. Okay, suppose we get no head. So that means we'll have all tells. Okay, so we have no heads. That means we'll have all tails. So we do not get head. Okay, now we'll get first head. Okay, and then next two tails. Then we get first tail, second head, and third tail. Then we'll get first tail, second tail, and third head. Okay, now this is no head. Here we get one head, and now we'll get two heads. So how we get two heads? So first head, second head, then tail. Okay, first head, second tail, and then third head. First tail, and then second and third head. Okay, and now we get three heads. Okay, so how do we get three heads? So we'll get first head, second head, and third head. Okay, so these are the all possible combinations. Okay, so this is being the sample space. Okay, so we got the sample space. Now for the probability, we need to know how many total samples points we have. So we can write here. Then we have. Okay, so what is the number of sample points we have? So you can count this. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have total 8 sample points. Okay. So as we know, the event is always a subset of this sample space. So any proper event is a subset of this sample space. Okay. So what is the first event we have? Exactly two heads. Okay. So the first event we have, so I'll consider let A be the event of getting exactly two heads. Okay, so this is the event exactly two heads. Okay, so we are getting two heads. Okay, now we need to write the sample points in A. So we have to collect all those points where we get two heads. Okay, so see the sample space. And now you can have where we have the two heads. So this is two head, this is two head, and this is two head. Is there any other where we get two heads? So we have only these three observations with two heads. Okay, and hence we write these observations here. So we get here first two heads, then first head, second tail, and then head. Then we have first head, tail, and then we have two heads. Okay, so this is the event we have. Okay, and now what we know, we have to calculate the number of sample points in A. So number of sample points in the event. So how many sample points we have? Three. Okay, and once we have the number of sample points in an event and number of sample points in the sample space, we are able to define the probability. Okay, so what we can say here, then the probability of getting exactly two gates is, so what we have, probability of the event A. The probability of event A is what? We know the number of sample points in A upon number of sample points in S. And here we have, this is 3 by 8. So what we got here? We got the probability of A is equal to 3 by 8. So this way we are able to get the probability of the event when we have exactly two heads. Okay, now what is our next event? So next event B is at least two heads. Okay, so what we have, let B be the event at least two heads. Okay, so what it mean by at least two heads means it is greater than or equal to two. Okay, so at least two. means what will be having greater than or equal to 2. So we can write the event B as so at least 2 means first we have to find a equal to 2 and then greater than 2. So we have H, H, T. See these observations, two observations, then H, T, H and T, H, H. So these are the observations when we have number of heads equal to 2 and then more than 2. What is the possibility more than 2? It is the only possibility that we will have of 3. Okay, so this way we are able to get the number of observations. Okay, and once we have the number of observations, what we can write is we can check how many observations we have. So we have here number of points in B is equal to, so we can count and this is equal to be 4. Okay, so we have the number of sample points in the event and we know the number of sample points in the sample space. So we are able to define the probability. So we can say the probability of getting at least 2 heads is, so what we know is probability of B is equal to number of sample points in B upon number of sample points in S, and this is going to be 4 by 8, so it's going to be half. Okay, so whenever required, then only convert this to decimal places, otherwise let it be in the simple fraction. Okay, and hence we get here the probability of the event is half. Okay, so this way we are able to calculate the probability of this event P. Okay, now let us see what is the event next. The next event is at most 2. Okay, so what we have at the most 2. Okay, so at most 2 heads. Okay, no more than 2 heads. Okay, so we have let C be the event at most 2 heads. Okay, so when I say at most 2 heads, that means the heads is less than or equal to 2. Okay, so number of heads less than or equal to 2. So that's what we have to consider. And hence we write the set. So less than 2, that means it will be 0, 1 and 2. Because we have equal to here, so we have to consider 2 also. So we have 0 heads. So it will be uh, tail first observation, all tails. Then second type of observation, one head. So we can have head, tail, tail, and then we'll be having tail, head, tail, and then we'll be having tail, tail, head. And then what next we have? Two heads. Okay, so two heads. That means head, head, tail. Then we'll be having tail, head, head. Then we'll be having head, tail, head. Okay, so these are the observations we have. So we got the sample points in the event C. Okay, and once we got the sample points in the event C, so we need to check. Okay, how many sample points we have. So what we have number of sample points in C. Okay, so we have to find out how many sample points we have, and you can count, and this count is 7, right? Okay, so we have the number of sample points in the event C is going to be 7. Okay, and hence I can write the probability of getting at most 2 hits is. So what we have as per definition, probability of C is equal to number of sample points in C upon number of sample point in S. So it is going to be 7 by 8. So we got here that the probability of C is equal to 7 by 8. So this way we are able to calculate the probability of the event when we have to get at the most two heads. Okay. Now we need to see what is the next event. Okay, so next event is there are no heads. So you can see the sample space, and then you can guess the observation where there are no heads. So these observations contain head, but this observation does not contain head. So this is the observation with no head. Okay, so let us define the event. Okay, so the next event we define as, let D be the event that we have no heads. Okay, so no heads is what? Zero heads. Okay, so we have zero heads. So there is the only observation when you have all tails. Okay, so what will be having here? Number of points in the event D is 1. And once we know the number of point in B, then we are able to write the probability of getting no heads is. Okay. So what is the probability you will be having? Here, the probability of D is equal to number of points in D upon number of points in S. So we have, this is 1 by 8. And hence we can write the probability of D is equal to 1 by 8. Okay. So we got here the probability of D is equal to 1 by 8. Okay. And that's how we are able to get the probability of all the events. So here we have considered a random experiment with the coin tossing price. Okay. So do you have any doubt this example? Okay. So do you have any doubt in this example? Okay. Uh, that's great. No problem. So we'll go for the another example then. Okay. So now we have seen this coin tossing experiment. Okay. So where we have tossed this coin 3 times. Okay. Similarly, we can toss this coin multiple times. Okay. So again, we'll consider the another random experiment of throwing a die. Okay. So let us consider the experiment of throwing a die. Okay, so a fair die is rolled, then find the probability of first. Okay, so the face shows even number. Second, the face shows odd number. Third, the face shows prime number. Fourth, the face shows perfect square. Okay. Then we can go on adding more. Okay. So you can say 5. The number whose square is less than 10. Okay. So these are the different things or the different events that we have to consider when we have roll a fair die. So fair die means it is unbiased. Okay. So if it is biased, it will not give you the correct result. Okay. And this whether the die is biased or the die is fair die, that will test in the next semester. Okay. So right now we assume that the die is going to be a fair die. Okay. So let us find the probabilities of these events. Okay, so first when we have to see the probability, first we have to write the sample space if possible. Okay, so let we have S be the sample space where a fair die is rolled or thrown. Okay, so we have what are the sample points in this experiment. So what will be the sample points in this experiment? You are throwing a die. Okay. So what will be the possible outcomes? Yeah. Okay. So it will be the numbers from 1 to 6. Correct. Okay. So it will be 1, 2, 3, 4, 5, and 6 because we assume fair die is a cube with the 6 faces and each face is numbered with the face number. Okay, so we have 6 faces, so we'll have 6 numbers. So we'll have these numbers as a outcome, or this will form the sample space. Okay, so in our sample space, we have this 6 points. So we have 1, we have 2, 3, 4, 5, and 6. Okay, so this way we have the 6 sample points. Okay, and hence we can write number of sample points is equal to 6. Okay, so now we have to consider this events one by one. Okay, so let us consider what is the first event. The face shows even number. Okay, so we consider the event A. Okay, the number is even. So let we have the event A that the number is even. Okay, so the face number is even. So what we'll be having? What is the sample space we have here? So we have the even number 2, 4, and 6. So we have 2, 4, and 6, and then we have number of points in A is equal to 3. Okay, so once we get the event and the number of points in the event, we are able to write the probability of this event. So we can write here the probability of getting even number is. So what is the probability we have? Probability of A is equal to number of points in A upon number of points in S. So it is 3 by 6, which is very easy. So it is half. So you'll be having the probability of A is equal to half. So we got the first probability. So the probability of the first event. Now, what is the next event we have? So see, the next event is that the face shows odd number. Okay. So here we have the face shows odd number. Okay. So let us consider this event. Okay. So we have defined the event B. So let B be the event. Okay. So what is the event? The number is odd. Okay. So we can write what are the sample points in P. So we want to calculate the odd number. So we can have 1, 3, and 5. So you can see from the sample space. Okay. So we have to always assume the sample space as a universal set. And then from the sample space, we have to find the observations fulfilling our criteria. So remember one thing that sample space is a superset for us, and then our events are the subsets of this superset. Okay. So here, what are the odd numbers we have? 1, 3, and 5. So these are the odd numbers. So in event B, we'll get this odd numbers. Okay. So what is how many observations you have here then? Okay. So you have the number of observations n number of observations in B is equal to 3. So once you have the number of observations in B, then we are able to write the probability of this. So we have the probability of getting odd number is. Okay, so here we want to get the odd number, and hence what we have, the probability of B is equal to number of points in B upon number of points in S. Yeah, because S is our sample space. So here we have 3 by 6, so which is again 1 half. Okay. So here we got probability of B is equal to half. Okay. So we have the probability of the event B. Okay. This now let us see the next event. Okay. So what is the next event we have? Next event is the face shows prime number. Okay. What we have? The face shows prime number. Okay. So let us see how many prime numbers we have. Okay. So let see with the event. The number is prime. Okay. So here we have see the number is going to be prime now. So can you tell me what are the prime numbers in the sample space? So you have the sample space, then you have to get the prime numbers. Okay, so what are the prime numbers we have? Yeah, what is the definition of prime number we have? Any one of you can unmute yourself and then tell me the definition of prime number. Any one of you? Then how did you decide that these are the prime numbers? It has factor 1 and the number itself. So why we do not consider 1 itself? Why do not consider 1 as a prime number? Because 1 divides 1 only, so 1 has factor 1 only. numbers that have only two factors, so one and themselves. Yeah, but my question is then why do we do not consider the number one?
Sir, one is nor prime nor composite.
Yeah, but then why we should say that one is not prime? Because if you say, as per the definition, one has the number who has the only factors one and itself. So one has the only factor one, one and itself. One has, so when you consider the prime number, you must mention the condition that the number is greater than or equal to 2. Okay. So this is the thing that we miss the small things. Okay. So number is greater than or equal to 2 and then the condition. Okay. So that's why we do not consider one as a prime number. Okay. So you got the point now, and hence what we have here. So we got the observations. So the sample points in C. Okay, and hence what are the sample points in C? We have 2, 3, and 5. And again we can see the number of sample points in C. Okay, is equal to 3. Okay, so once we know the number of sample points in any event, then we are able to define the probability. So we can say the probability of getting prime number is, so what is the probability we can have? We can write the probability of C is equal to number of sample points in C upon number of sample points in sample space. So here we have, this is 3 by 6. So which is going to be half. Okay. And hence we can write here. So the probability of C, okay, is going to be half. So we got the probability for the event that the face shows prime number. Okay. Now let us see what is the next event we have. So the next event is the face shows perfect square. Okay. So now the face shows a perfect square. So this is the event that we have. So what will be having? Let D be the event. The number is perfect square. Okay. So we need to check what are the sample points in D. So can you tell me what will be the sample points in D? So the number should be a square. So you have the list from 1, 2, 3, 4, 5, 6. Okay, so you have the list and you have to choose the squares in this list. So what are the squares in this list? Yes. Okay, so you got it. Very good. So these are the only squares in this list. Okay, and hence we got the sample points in the event D. So what are the sample points in the event D? So we have 1 and 4, and hence we have the number of sample points in D is equal to 2, and hence we can write the probability of this event. So we can write the probability of getting perfect square is. So what is a perfect square we have? So probability of D is equal to number of sample points in D upon number of S, sample points in S. So what we have, number of sample points in D and number of sample points in S. So we have, this is 1 by 3. And hence we got here the probability of the event D is 1 by 3. So we got the probability of the event. Yeah. Now, what is the next event we have? So you can see the next event is the number whose square is less than 10. Okay, so what is the condition? The number whose square is less than 10. Okay, so let us see what are such numbers. Okay, so we have the next event. So let E be the event, the number with square less than 10. Okay, so that is the event we have. And hence, what will be the sample points in the event? So you have to choose a number such that whose square should be less than 10. So what are the numbers whose square will be less than 10 in this list? Okay, so 1 square is 1, 2 square is 4, 3 square is 9, 4 square is, what is the 4 square? 16. So is it less than 10 or more than 10? 4, correct. Okay, so that means we cannot have 4. Okay, so we can have at the most up to 3. Okay, so the observations are 1, 2, and 3. Okay, and hence we have the observations in the event E as 1, 2, and 3. Okay, so we have the number of sample points in event E is 3, and hence what we have here, so we have the probability. So we can write the probability of getting the number square is less than 10 is. So what is the probability we have? Probability of E is equal to number of sample points in E upon total number of sample points. So it is 3 by 6, and which is going to be half. So what we have here, and hence we have the probability of event E is half. So we got here the probability of the event is going to be half. And now you can see the observations that I have given to you. The probability is never negative. So have you got any probability in both of this example to be negative? Yeah, so all the probabilities are positive. The next thing is that you can see the probability of all proper events is less than 1. So you can see 1 by 8 is less than 1. Here you can see this is half, which is less than 1, half less than 1, half less than 1, 1 by 3, which is less than 1, and then again we have half less than 1. Okay, so here uh, as we have the probability of any proper event, okay, is less than 1, okay, and the probability is always positive, so greater than 0. Okay, so it is greater than 0, it is equal to 0 in only the case when you have the impossible event or the null event. Okay, so here we have observed that the probabilities we have got, okay, are positive and less than 1. So for all the events, the probability is always less than 1, okay, or at the most it may be equal to 1. Okay, so that's what we have. So do you have any doubt in the two examples that we have solved? Okay, okay. No problem. That's good. You don't have any doubt. Okay. So these were the examples where we have considered the basics. Okay. Let us consider another example. Okay. And then let us see how we can have the more number of sample points. Okay. So let us try this. Okay. So let's have an example. So we'll have another example. Okay. Find the probability of following. Okay. So first, the sum is more than 10. Second, the sum is 7. Or the sum is less than 5. And 4, the sum is more than 10. Uh, 5 is told twice, and the observations are noted. Okay, so what is the random experiment actually? The random experiment is we are rolling a die twice. Okay, so that's what we need to understand. Die is roll twice. So we'll have the observations in pair. What may be the first number that we'll get for the first roll, and then we'll get the what will be the number we'll get for the second throw. Okay, so here we need to write the sample space properly. So if you can write the sample space properly, definitely you are able to get the solution and you will get the correct probability. So what we have let as be the sample space when a die is rolled twice. Okay, so we have now what we have to do is we have to write down all possible pairs. Okay, so when we roll a die, what are the numbers we'll get? 1 to 6. Now when we'll roll that die twice, so we'll have that 6 by 6 list. So the list with the 36 elements. Okay, and hence we'll write this list. So if you write this list in a proper way, then definitely you will get the events easily. Okay, so let us write the list. So may possible that first I'll get 1, and then in the second I'll get 1. Okay, may possible that first I'll get 1, and then in the second I'll get 2. May possible in the first I'll get 1, and second I'll get 3. Then I'll get 1 and I'll get 4, and then I'll get 1 and I'll get 5. Then I'll get 1 and I'll get 6. Then I'll get 1 and then I'll get 7. Is that possible? Can I get a 1 and 7? No. Okay, because we are limited to 6 only. Okay, and that's why 1 to 6 we have to consider. Okay, so let us try this. Okay, so we'll have 1 to 6, and now the same thing we can repeat for 2. So we have 2 1, then 2 3. So write down the list with me. So here I have is going to be 2 2 also is possible. Okay, so 2 2, 2 3, then 2 4, 2 5, and 2 6. Okay, then we have for 3. So 3 1, 3 2, then we have 3 3, then we have 3 4, then we have 3 5, then we have 3 6. So there is a benefit of writing the list like this. So later you will come to know what is the benefit of writing the list like this. Okay. So first follow this style, and then I'll show you what is the benefit. Okay. So we have for the 4, so that is 4 3. Then we have 4 4. Then we have 4 5, and then we have 4 6. Okay. So we have 4 6. Okay. Next we can have for 5. So we have 5 1. Then we'll be having 5 2. Then we'll be having 5 3, and then we'll be having 5 4. Then we have 5 5, and we have 5 6. Now we can write for the 6. So we have 6 1. Then we have 6 2. Then we have 6 3. Then we have 6 4, and 6 5. And finally we have 6 6. Okay. So this way we are able to get the list of all possible observations. Okay, so this is a list of all possible observations when two die is rolled twice. Okay, or we can say two dice are rolled. Okay, so the observations are going to be same. So if two dice are rolled or a die is rolled twice. Yeah, and you can see how many observations are there. So we have this 6 rows, and then we have 6 columns. So this is the 6 by 6. So if I consider in terms of the matrices, okay, then this is a simple 6 by 6, and so we have 36 observations possible here. Okay, or we got the total number of observations, hence number of sample points in years is equal to 36. Okay, so we got 36 here, and now let us see the events one by one. Okay, so what is the first event we have to consider? Okay, so first event is the sum is more than 10. Okay, so the sum is more than 10. Okay, so what we can have is, so we have to find the observations such that the sum is more than 10. So what we'll be having, A is the event, the sum of observations is more than 10. Okay, so more than 10 means what? Okay, what is the minimum sum you have? 2. This is the minimum sum. What is the maximum sum you have? 12. Okay, so more than 10. Here the word is written more than 10. So it is strictly more than 10. Okay, so strictly greater than 10. So if you have 10 and more than 10, then we will have included this 10. But here it is given that it is strictly more than 10. So we have A is equal to. So what are the observations you will have in A? Okay, and now see how to find the sum uh, more than 10. So we want the sum to be more than 10. So you can see it can be easily done. Okay, so see, I have 6 plus 4 is 10. So I want more than 10. So these are the observations which have the more than 10. So here the sum is 11, and for this line the sum is 12. And you draw the line here, it will, all the observations on that line will have the same sum. Okay, and that's why I have asked you to write this way. So here there are two lines which having sum more than uh, 10. So this is the line with the sum 10. So we have to consider only those observations who lie on these two lines. Okay, and that's why we have written the observations in this manner so that we can easily get this. Okay, so now we got the observations. So we'll write what are those observations we have. Okay, so let us write those observations. So we got 6 5, 5 6, and 6 6. So we have here these observations are 6, 5, 5, 6, and 6. Okay, so these are the observations. Hence, what is the number of points in A? So the number of points in A is 3. Okay, and once we get the number of points in the event, then we are able to find the probability. So we can have the probability of the event A is, so what will be having probability of A is equal to number of points in A upon number of points in S. So it is 3 by 36. So we can say 1 by 12. Okay, and hence what we got? We got the probability of A is equal to 1 by 12. Okay, so this is the probability of the event we got. Yeah. Now, what is the next event we have? The sum is 7. Yeah. So we have the next event. We can say let B be the event. The sum is 7. Okay. So you can see the observations. Okay, and find where the sum is 7. So it is 6 1. Okay, and if it is a 6 1, so start the line from the 6 1 and draw that line diagonally. Okay, so this is the line which having the sum 7, and surprisingly you will see that this is the only line. Okay, so you don't have any other line with the sum 7. Okay, that's why I have told you to have the observations written in this manner. Okay, so here this is the only line which has the sum 7, and these are the observations which will have the sum 7. Okay, so let us write down this observations. Okay, so you can draw this line by pencil. Okay, for understanding. Okay, now we'll write the points in B. So we have the event B is 1 6 2 5 3 4 4 3 5 2 and 6 1. Okay, so these are the observations. Remember that 6 1 and 1 6 are different. Okay, so that's why we have to consider this in another way. So 1 6 is different than 6 1. So we have to be careful. Okay, and hence what we can say is the number of points in B. So how many observations we have? We have 6 observations. So we can write the probability of event B is. So what will be having? Probability of B is equal to number of points in B upon number of points in sample space. So it is 6 by 36. It's going to be 1 by 6. So we have here, this is going to be hence probability of B equal to 1 by 6. Okay. Now consider the next event. So what is the next event we have? The sum is less than 5. Okay. So we have the sum is less than 5. Okay. So now you know the line, how to draw the line. So sum is less than 5. So sum is going to be 2. Okay. So 1 1. Then it may be 3. So 1 2 and 2 1. Then it may be 4. So 1 3 and 2 2 and 3 1. Okay. And you can have the next sum will be 5. So if we want to see in the observations, so we can see these lines. Okay, so this is the line with some 2, this is the line with some 3, then this is the line with some 4. But if we go to this, it will be 5. And that's why we have to consider all the observations on these 3 lines. And you can see I have considered 1 1, then 1 2, 2 1, then 1 3, 2 2, and 3 1. Okay, so these are the observations that we have considered. Okay, and hence we have these observations here. So we have these observations here. Okay, and now see this observation. So we have 1 1 1 3 2 1, 1 1 1 2 2 1, 1 3 2 2, and 3 1. Okay. So now how many observations are there in this event? So NC is equal to. So there are 6 observations. So we can write the probability of the event C is. Okay. So what is the probability we have? So probability of event C is number of points in C upon number of points in S. So we have this is, okay, 6 by 36. So it is 1 by 6. So we got here the probability of C is equal to 1 by 6. Okay. And now consider the next event. So what is the next event we have? So we have the sum is more than 12. Okay. So next event we'll consider, let D be the event. So what is the event? The sum is more than 12. Okay, so now check your observations and then tell me, is there any line with the sum more than 12? That's true. So there is no line with the sum more than 12. Okay, so if there is no line with the sum more than 12, okay, then we can consider this is an impossible event or this is a null event. Okay, and hence we write here. Yeah, so purposely I have considered this event so you can understand the null event or the impossible event. So we can say there are no observations with sum more than 12. So this event P is a null event. Okay, and hence we can say directly the probability of that is number of points in D is equal to 0. So we have the probability of D is equal to 0. So we can see this is a null event and hence its probability is going to be 0. Okay, so therefore we have to consider. Okay, so here we got the idea of the null event also. Okay, and got the idea of running a die twice and so on, how to write the sample space and how to calculate the probability of the simple events. So is there any doubt in this 3 examples? Okay, so that's good. You don't have any doubt, right? Okay.